Okay, our aim today is how do we prove certain properties of a parallelogram. So if you remember, we already proved certain properties of a parallelogram. Namely, we proved that both pairs of opposite sides are congruent. We proved that both pairs of opposite angles are congruent, and we proved that consecutive angles were supplementary. We did that in 3 different proofs, and you can see that in 3 different videos. The last one we're going to prove, the last theorem, which is a property that we're going to prove, is that the diagonals bisect each other. Okay, so here's what we've got. Given parallelogram ABCD, prove that AC and BD bisect each other at E. In other words, prove that BE is equal to DE and prove that AE is equal to CE. How do we know that that's true? How do we know that that property is true? We're going to use triangle congruence to do that. And here's how we're going to do it. We have 2 options. We can either try to prove that triangle BCE is congruent to triangle DAE, or we can try to prove that triangle ABE is congruent to, and let's use another color, is congruent to triangle DCE. If we can show that, for example, the yellow triangle, DCE, was congruent to the red triangle, well, that would mean, because all the corresponding parts are equal, that would mean that BE was equal to DE, and that would mean that AE is equal to CE. So that is our objective. So it turns out that, notice what they're using. They're using the proof that triangle ABE and triangle CDE are congruent, and by doing that they can say that all the corresponding parts are congruent, namely that BE and DE are congruent and AE and CE are congruent. So let's see how we're going to go about doing that. So let me focus your attention on the 2 triangles we want to prove are congruent, the blue and the green. Okay, so first statement, ABCD is a parallelogram. Well, that is given. Next, so we have a bunch of statements that are missing, and we have some reasons that are missing. We're going to fill in each. You should be taking this down in your notes if you haven't already. They need to be in your notes. You need to know them. Okay, the next statement is definition of a parallelogram. Well, what is the definition of a parallelogram? Well, the definition is that line segment BC is parallel to line segment AD, and also that line segment AB is parallel to line segment CD. That is the definition of a parallelogram. Remember, it's given that it's parallelogram ABCD. So we know that these 2 sides are parallel to each other, and we also know that these 2 sides, AB and DC, are parallel to each other. Okay, well, next they're telling us that angle 1 is congruent to angle 4 and angle 2 is congruent to angle 3. 1 and 4 are congruent. So in other words, angle 1, which is right here, is congruent to angle 4. Why is that? Well, if I have 2 parallel lines that are cut by a transversal, that means their alternate interior angles are congruent. Remember, these are my 2 parallel lines. It's a parallelogram, so the opposite sides have to be parallel. What is my transversal? This is my transversal. AC is my transversal, which means that these 2 angles, angle 1 and 4, are congruent because they are alternate interior angles. And using the same parallel lines, BA and CD, but using BD as my transversal, you can see that angle 2 and angle 3 are congruent to each other. So why are those 2 pairs of angles congruent? Well, that is the alternate interior angle theorem. Namely, if 2 parallel lines are cut by a transversal, alternate interior angles are congruent. Okay, now remember, when you are trying to prove 2 triangles are congruent, you have one of 5 triangle congruence theorems or postulates to use. Now, while it is true that these 2 vertical angles are equal, that's not going to help me because AAA is not a proof of congruence, right? But what can I use? I can use another theorem that I know. I can use other properties, which we know are also theorems, that I know. Namely what? Namely that opposite sides of a parallelogram are congruent. In other words, I know that BA, side BA, and CD are congruent to each other. And that helps me because then these two triangles, triangle ABE, and triangle CDE will be congruent because of angle, side, angle. Two angles and the included side. So my fourth statement is going to be line segment AB is congruent to line segment CD. Why is that? Because opposite sides of a parallelogram are congruent. So let's see what I have so far. I have two angles over here. I have a side over here. And notice how this side, BA, is sandwiched in between angles 1 and 2. And this side, namely CD, is sandwiched in between angles 3 and 4. So I can say that these two triangles are congruent to each other because of angle, side, angle. Well, if that's true, if it's true that these two triangles are congruent to each other, let's see what I have. That means that line segment DE, and what I'm going to do is let me erase this since we've used that all, and let me add these two triangles in again so we can see what we're looking at. If these two triangles, the blue and the green, are congruent to each other, that means that BE corresponds to DE. So in other words, if you took this and rotated it around, these two correspond with each other. So I know that they would be equal to each other because all corresponding parts of congruent triangles are congruent. So I can say that BE is equal to DE, so BE, line segment BE, is congruent to line segment DE, and I can also say that AE, which is this piece right over here, is congruent to CE. So AE, let me write that more neatly. So I can say that line segment AE is congruent to line segment CE. And what's the reason for that? Well, corresponding parts of congruent triangles are congruent, or CPCTC. Well, what does that mean? Well, that means exactly what I'm being asked to prove. That means that AC, line segment AC, and line segment BD bisect each, EACH, bisect each other, exactly what I'm asked to prove. Why? Because that's the definition of bisector. A bisector creates two line segments that are congruent to each other. So this is the fourth and final proof for the fourth and final property of a parallelogram. This needs to be in your notes. Put your player on pause. Please make sure you take these down. They are important.